In geometry, a right solid is a solid whose sides are perpendicular to the top and bottom. So far, we have focused on finding the surface area of right circular cylinders and right triangular solids. In example 88.1, we're going to find the surface area of the right triangle solid shown. Dimensions are in meters. So we have an end that's a triangle, so we have a front and a back that match, the two ends match. And we have the upright leg is 4 and the bottom width is 3. And we have 2 of them, and we know for the area of a triangle we say base times height divided by 2, and because we have 2 ends we're going to multiply by 2. So that calculation is going to give us 12 meters squared for both ends, or both triangular ends. Now we're going to look at the lateral surface area, or the area around the triangular shape. So if you look at the back, it's 4 tall, the bottom is 3 meters wide, and the slope part is 5 meters wide. So when we add those three, or the perimeter, I guess, together, we get 12 times 16, which is the length, which is going to give us 192 meters squared. When we add that to the area of the ends, which was 12 meters squared, we get 204 meters squared for our total surface area. When we first started talking about finding the lateral surface area of a shape, we used a soup can as an illustration. If you were to take the soup can and peel the label off of that soup can, you would find that it was just a rectangle. And we know how to find the area of a rectangle. We know that it is the width times the height, or the length, whatever you want to call it. But if you look at the right circular cylinder, which is your soup can, the top of that label, which is the width, that's just the circumference of the circle that's on the end. So if you find the circumference or the perimeter of the end, or the top or bottom of your shape, and you multiply it times the height of that shape, you're going to find your lateral surface area. So now we're going to do example 88.2, where we're going to find the lateral surface area of a right solid 10 meters tall, whose base is the figure shown on the left. So first we're going to break this into 2 parts. We're going to do part 1, or perimeter 1, where it is the flat sides. These are the sides that we can identify the length of pretty easily and add them together. So we have 30 meters on the top, we have 16 meters on the right side, and 30 meters identical to the top on the bottom. So don't forget that, even though it's not written. So 30 meters plus 16 meters plus 30 meters is 76 meters for part, or perimeter 1. So now we're going to look at the second part, which is a circular end, or a half circle. We're going to call that part 2, or perimeter 2. So we know that the circumference of a circle is 2 pi radius, but because it's a half circle, we're going to divide that in half. We're going to divide it by 2. And we know that 2 times the radius is just the diameter. So the diameter pi is the circumference formula also. And we're going to divide that by 2. And we can tell by looking at the right side of our figure that the diameter is 16 meters. So 16 pi meters divided by 2 is the perimeter or circumference of part 2. So we're going to add the perimeter from part 1 and part 2 together. So we have 76 plus 8 pi, and that's in meters. And it's okay to write it like that. You don't have to multiply 8 times pi. It's actually more accurate not to. We're going to multiply that times the height of our shape, which is 10 meters. And that's going to look like 760 meters square plus 80 pi meters square. And we're going to kind of write that in standard format, where we just put the numbers together in parentheses and meter square on the outside. So 760 plus 80 pi meters square is our lateral surface area. So let's review. Lateral surface area equals perimeter times height. When we write area, the unit of measure has an exponent of 2, or is squared. Total surface area equals the lateral surface area plus 2 times the area of the base. As always, thanks for joining us at Jupiter Math. If you have any questions or would like more information about our math programs, contact learning@edugraphics.com.